We are going to actually calculate this exactly, so we are not estimating. We're going to use the calculator to find these exact values. We might have to approximate by rounding, but we're not just kind of looking at the graph to see, oh, it looks like it's this or whatever. So all I've done is I've gone into y equals, and enter the equation that's right here, just exactly how you see it. Make sure you clear out anything else that is in y equals. And for this graph, you're welcome. I made it nice for you so that on your normal window you can actually see all the points that we need to see. So the first thing we're looking for is the absolute max. So that's going to be the very tip top, the highest point that the graph gets to, which is right that point right there. So we're going to calculate that. So we're going to go into second, calculate. We're going to do a maximum. Now we need to be on the left of that point right there, not necessarily like the left of the graph. I mean, it will be on the left of the graph, but we're trying to be on the left and then on the right of that specific point. So we're going to go to the left of it, anywhere to the left is fine, and then go to the right of it, and then it's asking you if these bounds are where you're looking between, so double check and make sure that your point is between there, and then hit enter one more time. And this is the number, this is the ordered pair that we're going to round. So we're going to put negative 2.141, negative 0.852. That is the absolute max. To find the local max, we're going to do the same thing, but we're going to do it on this one. This is a maximum of the function, at least regionally. It's not the overall maximum, but it is still a maximum. So we're going to do the same thing. Go into second, calculate. We're going to do maximum again. This time, I need to be on the left and then on the right of that point right there. So that's good for the left. I'll go to the right of that point. It's asking you up here, is this the window that you want to calculate on? Yes. So we're going to call that 0.432 and negative 4.413. That is the local max. Okay, this graph, because of the way that it is acting, where it's starting down and ending down, it just has one minimum right here that's a local minimum, and then the absolute minimum would actually, this graph would go all the way down to negative infinity. So the absolute minimum we weren't asked for in the problem because it would be negative infinity, but we do want to still calculate that local minimum. So go into second, calculate. We're going to find the minimum this time, and we want to be on the left and the right of that minimum point. So we'll go to the left of it, and we'll go to the right of the minimum. And again, there's the window it's asking, yes. So we're going to call that negative 0.541, negative 5.693, rounding to 3 decimal places because we can read and follow directions. Okay, and then this is, we're going to have 2 intervals where the graph is increasing, so we kind of have to think through this. It's not asking when is the graph positive, it's asking when is it going up. So if it's starting down here at negative infinity, the only place it can go is up. So my first interval on which it's increasing is starting at negative infinity, and it starts going up and up and up and up and up and up and up, and it goes all the way up until it gets to this point, which was my absolute maximum. And that x value of that point we have recorded as negative 2.141. So it's increasing all the way from negative infinity all the way up to that point right there, which was negative 2.141. We would normally, when we were doing range, we would put a bracket right here because we actually can touch that point. And though we can still touch that point, the graph is not increasing at that exact point. So it increases all the way up until the point, but not including the point. So I actually put a parentheses on this one as well. So that's kind of new for us in this unit. The other time that this graph is increasing, so it's increasing here to here, it gets to that point, and then it starts to decrease. So this is going to be a decreasing interval right here. In fact, let's go ahead and record that on an interval that is decreasing. So we start decreasing, not exactly at negative 2.141, but just after it. So we put the parentheses there instead of the bracket. So from this point down to the minimum is when I am decreasing. So that minimum value is negative 0.541. These are the x values where the graph is decreasing. Same rationale for why this is a parentheses, because it decreases until it gets to that minimum, and then momentarily it doesn't decrease, it switches, directions. So from down here and then all the way to this little tiny bit right here, we're increasing again. So we were increasing from negative infinity up to here, and then we increase on this little tiny segment right here. So that increasing segment is from negative 0.541 to that local maximum value, which is 0.432. And then after it crests right there, it's going to start decreasing again, and it continues decreasing all the way back to negative infinity. So it starts decreasing at that local maximum value, which was the 0.432. And it continues decreasing until we get all the way to negative infinity. So you can see if you put all of these, well, this one was first, and then we did this one, and then this one, and then this one. If you put all four of these intervals together, taking out, of course, the actual turning points that aren't included as increasing or decreasing, it's momentarily stopped, you would have the full negative infinity all the way back down to negative infinity. It would cover the whole range of values there. Actually, this one should be positive infinity, because the graph is going down to negative infinity, but the x value is going out to positive infinity. So we're starting here at negative infinity at the beginning of the graph. My x values, if they went all the way out to negative infinity, would start way down here at negative infinity, and then it would start increasing. And then as we get to the end of this graph, my x values continue to go out to positive infinity. So if you put these intervals together, you'd have the whole range of real numbers.